Hello everyone. Uh, it's been a little while, and I have decided that we can begin a quick series of reviews of the 2025 AIME problems, both the AIME I and AIME II. What I suspect is that with the AIME cutoffs most likely going to be released soon, somewhere in the middle of this series, those of you who will make it into the AIME are going to find out. So congratulations to those of you who do make it into the AIME when that time comes. If you have unfortunately missed out on the AIME, I think it's still useful to do some preparation because the AIME is going to take place usually 1 month and a bit after you find out you get in. And the gap between the AIME and the AMC 10 or 12 is pretty large. So there is no way that after you find out you get in, you are able to get to the point where you can do well for the AIME unless you have already had some sort of practice and some sort of preparation at that level. Before we go through the problem, since this is the first video of the series, I just want to give a bit of a heads up, which is that the AIME score is combined with the AMC score to determine the USAMO or USAJMO qualifiers. Now, the AMC 10 score and the AIME score would be used to determine the USAJMO qualifying index. And if you had the AMC 12, A or B, plus the AIME, that would be for the USAMO. Now, for Singaporeans and non-Americans, we cannot actually take the USAMO or USAJMO. So the only achievement you can get from taking the AIME is that you get a total score / index that allows you to say that I qualified for the USAMO, and some of you will say I qualified 5 times, I qualified 3 times, or however many times that is. That is also an achievement, and frankly, the only achievement that you can concretely put down from the AIME. However, there has been a rule change in terms of the computation. And you see that for the AMCs, we know they're out of 150, and for the AIME, they are 15 questions worth 1 mark each. So it made sense that the index was calculated by scaling the AIME up by 10 so that it is 150 each. However, for this AMC cycle, the MAA has decided to change it to 20 times of the AIME score, which means that the AIME cutoff, the USAMO cutoff would depend more on the AIME than your AMC score. This also means that it is pretty difficult to say definitively what would be expected cutoff index. You can find the historical indices, but those would be out of 300, whereas now this is out of 450. Nonetheless, I would say that as a very broad statement, if you are hoping to get into the USAMO, something like 10 questions on the AIME should be like a starting target. A bit more or a bit less depending both on difficulty and your AMC 12 score. And if you're hoping for getting into USAJMO, then somewhere about 7 to 8 will be your starting target, again depending on your AMC 10 score as well as the difficulty of the paper. Okay, so that's just for context because especially if you are not American, you may not be aware of this, and also you may be wondering what is the purpose of the AIME, do I get a prize? So the answer is this is the result. If you hit the cutoff, you will get to say that you are a USAMO qualifier or USAJMO qualifier. Alright, now that brings us to talking about the problems, and in this video I'm just going to go through questions 1 through 5. Questions 1 through 5 of the AIME would normally be still within reach for anyone who has qualified for the AIME because it means that you have done some harder AMC 10 or 12 questions. If it's your first time qualifying, I would suggest that you put in most of your effort on questions 1 to 5 and try to make sure you get them correct. Because you have 3 hours for 15 questions, but in reality, you're not going to seriously attempt all 15. You essentially have unlimited time. So really try to get them right. Having said that, for those of you who are aiming a bit higher, we can usually go through them pretty fast. So I will go through it pretty quickly because solutions are not that long, but bear in mind that you essentially have unlimited time unless you are aiming for more than 10 questions. Alright, so question 1. Find the sum of all integer bases b greater than 9 for which 17 in base b is a divisor of 97 in base b. When it comes to bases, once in a while there will be some sort of philosophical understanding of how things work in base b that would allow you to be happier to work in base b. This is not one of them. This is a situation where you would just convert this and say that this is b plus 7 and this is 9b plus 7, and I now just want to make sure that b plus 7 is a factor of 9b plus 7. The way we do that is that if you wrote this as a fraction and you did either a simple manipulation or long division, the quotient will be 9 and the remainder will be negative 56. This means that you just want b plus 7 to be a factor of 56, with b being greater than 9 as the constraint, otherwise the digit 9 would not make sense. Now, that means that b plus 7 is more than 16, so there are only going to be a couple of big enough factors, which is 28 or 56 itself. So b is 21 or 49, and your first answer is 70. Now, take note that I am boxing this up and saying 070. For the AIME, if you are doing it on paper, my latest understanding is that you will shade in 3-digit numbers including leading 0. So if your answer is 5, you put 005. If it's 0, then you put 000. 3-digit numbers. All AIME questions have answers that are integers from 0 to 999 or 000 to 999. Having said that, I'm not 100% sure of the online platforms. So if let's say you're doing online, I'm not 100% sure whether you have to type in the leading zeros. Just do check the portal whenever you are doing it online, because the rules do sometimes change from year to year. Okay. Number 2 is a huge diagram where I need to almost zoom out and shrink the diagram to get it to fit within the screen. So let's shrink this down. I think that is now all within our frame of view, and this is also a pretty long question, but all of it seems to just be talking about the length of things. So let's label all of those lengths. Clearly not to scale. And the first thing that you would immediately realize is that these are proportional to each other in the ratio 1:4:2. That means that if they are proportional, these are all going to be parallel. That is true whether you use a so-called intercept theorem or you just say that it is SAS similarity between ADF, AEG, and ABC. Now I have a couple of reflections. The reflections just can be taken as equal lengths, except that you have now extended it out collinearly. We are then given that the area of DEGF is 288, that's the middle portion, and we're asked to find the area of this weird shaded heptagon, although I would definitely not describe this as a heptagon. It does have 7 sides. but no one is really thinking of it as a seven-sided polygon. The idea is actually just going to be repeated at the three different layers with three slightly different looking iterations of the same thing. Namely, all of these here can sort of be just shifted inside. They have the same area because they have the same base and the same height. That happens on top, so you can shift it into here. But that also happens that you can shift this part into here while leaving the EBC portion untouched. The last bit, which is slightly more unusual looking, you can also say that this is actually the same area as the middle portion because it is a trapezium. So this trapezium and the trapezium DEGF rather, have the same height, the same two bases. So it would also just be shifted inside, which means that essentially your conclusion, if we also shade this part that was already there, is that 288 is the area of DFG, and this is just the area of ABC, the triangle. From there, what is left is just similar triangles, because this is in the ratio 1:4:2. That means that I can find the ratio of the area of the three layers. I'm going to draw it separately here. That this is 1:5:8. Sorry, not 8. 1:5:7. Beg your pardon. And so the ratio of areas inside is 1 is to, this would be 25. So minus 1. And then this whole thing again would be 7 squared. So 49 minus 25. So that's the ratio of areas of those layers is 1:24:24. DEGF is 288. So my answer would be 288/24 multiplied by 49. So this one is a pretty typical example of how AIME questions near the front, there's an attempt to use simple ideas but just bring them up in apparent difficulty. So although this is not a terribly hard question, it is entirely understandable that at one look you may panic. That's where 3 hours comes in. Right? Do not feel compelled to go in order. Do not feel that you have failed if you are stuck on question 1 or 2. Just move along, and then as much as even 45 minutes later, you can come back to the question. The longer the time, the fresher your thinking is if you are completely stuck. Okay. Question 3. Now, 3, 4, and 5 are all to do with some kind of counting the number of ways to do a task. Unlike the AMC, it is not multiple choice, so you don't really get the help of, oh, I have a chance that my answer is none of the above and then I catch the error. That's not going to happen, and so we need to be extra careful that we do not mess up in that way. For this one, let's read it carefully. There are 9 members of a baseball team. They each had a single scoop of 3 possible flavors. At least one player chose each flavor. The number of players who chose chocolate was more than the number who chose vanilla, who is more than the number of players who chose strawberry. So basically, this means that you can write down the information as so C, V, and S, chocolate, vanilla, and strawberry. This is the total, there are 9. And this is the other statement, which is that they are in this order and all are at least 1. Whenever there's a counting question, you should always just ask yourself, can I list out the possibilities in like a short time? We only look for cleverer things if you can't list. If let's say that there's just a list of 5 possibilities and I can see what all 5 of them are, I am not even going to think harder anymore. So I can see straight away that this is quite restrictive. This is quite restrictive because they sum to 9, they are increasing and they start from at least 1. If I went 1 plus 2 plus 6, that's one possibility. 1 plus 3 plus 5, that's another possibility. 1, 4, and 4 doesn't work, and then 2, 3, 4 is already 9, that is it. So there are only 3 cases. 3 cases for the number of different instances of each flavor. Then you just arrange these. So if you just arrange these, compute it carefully, this is 252. This would be 504. And then this would be 1260. If you add them up, it makes sense why they ask you for the remainder when divided by 1000. This just goes past 1000. 2016, and your answer you give is 016. Now, question 4. Another counting question. X and y are integers, and you have this equation 12x squared minus xy minus 6y squared equals to 0. This is a quadratic. Since this is a quadratic, my first instinct is to see whether I can factorize it. Now it's a quadratic that goes x squared minus xy minus 6y squared. Of course, you can just start trying to factorize it. But a small trick is that we can use the discriminant to sort of test whether it is factorizable, and whether you want to actually use the quadratic formula is up to you after that. Right? So the discriminant turns out to be equal to 17 squared. So that means that it is factorizable. Whether you want to factorize it or now just use the quadratic formula in order to determine the factors is up to you. Anyway, once you have done the factorization, you would get 3x plus 2y, 4x minus 3y equals to 0. This is not that difficult to do because if you are trying to do the factorization, we know that each of these cannot have a common factor. So it cannot be odd and it cannot be even and even coefficients in the same side. It cannot be multiple of 3 coefficients on the same side. So that greatly reduces the number of possibilities we have to consider. So anyway, this would give me a pair of cases, which is that 3x equals to negative 2y or 4x equals to 3y. Now I want to divide and say that this means y is negative 3 over 2x or y is 4 over 3x. Just that we need to be careful that 0, 0 will be an overlap. That's the one thing that I need to watch out for. Well, the other thing I need to watch out for is just to make sure that they fall within the range, right? Minus 100 to 100. So for 3 over 2 times something to fit into this range, I can go up to 66. Where your y will be plus minus 99. To go up to here, I can go up to 75. And so we can count that there would be 66 cases here. There will be 50 cases here. And then this 1 is double counted, so 66 plus 50 plus 1. Finally, in number 5, there are 8 factorial ways to arrange 1 to 8 is something we already know. We are basically asked how many of them are divisible by 22. For those of you who are watching from Singapore, I guess the kind of question here would be something that you could see in the certain years of the SMO Junior Round 2 also. Right? This looks a bit like Junior Round 2 questions. And I would say that for the AIME, any of the easier counting or geometry or number theory or algebra questions that do not involve, let's say, trigonometry, complex numbers, or circle geometry. It looks simple. It's good practice for the SMO Junior Round 2 as well, because that's the kind of difficulty that we're talking about. Okay, so anyway, what exactly is special about 22? It is 2 times 11, so I can use divisibility tests on this. There are 8 digits. I'm not going to be too creative in my naming. I just know that H is even, and I know that the odd placed and the even placed digits are congruent in sum mod 11. I know also that 1 to 8 are the set of digits. So it is a fixed sum of all 8, which is going to be the sum of both sides. Now, this clearly means that the only way you can do it is for it to be 18 and 18, because if you want them to be congruent mod 11, the next thing you can do is just shift it to 29 and 7. But if I shifted it to 29 and 7, that will also be impossible because 4 numbers cannot sum to 7. So this is the only possible way that you can get them to satisfy the divisibility condition. We are now left with a counting question. I now have to decide on how can I get 4 numbers to sum up to 18. But I technically splitting into 2 halves, right? So I can assume that let's take the half that contains the number 8, so it's easier. The half that contains the number 8 uses 3 numbers that add up to 10. So I think I can list that 721, 631, 541, 532. And then there would be the complement, which it's not very hard to write them down, so I will just write them down explicitly. we know that there is no other constraint except for h being even. And conveniently enough, all of these are containing two even numbers each. So if they all contain two even numbers each, then there would always be two choices for what to put down there, which allows me to handle all of these together. As long as I remember to multiply all the things that I should multiply, I am okay. So step one is that I need to decide which of the quadruples goes into the odd place and the rest will go into the even place. So there are 8 choices for which one goes into the odd place, which goes to the even place. From there, I can arrange the odd place ones, A, C, E, and G, any way I like. And for the even place, I can arrange it once I've ensured that H is even. So I can do that in 2 ways for H and 3 factorial for the rest. I can calculate this. That would be equal to 2304. And so this question asks you weirdly to just subtract 2025 as the answer extraction. We can do that. And so the answer is 279. So I'll say this is not too bad. It is a good example of a problem that is around that question 5 of the AIME because of the many ways in which you can go wrong. You can accidentally forget a case, you can forget they can flip around, you can forget to multiply by 2, you can forget that you cannot have any of the 4 factorial ways at the back, or you could have not realized that they have two even numbers each and split it into 8 cases and ended up doing a lot of computations. You would notice that I'm almost talking slower for the AIME reviews than for the AMC. You should have a little bit more time to think and a little bit more of a methodical and calm approach when tackling the AIME problems. So try to go at a steady pace, but look out for all the shortcuts you can have, because not only does that save you time, it reduces the chance that you lose a mark on a careless mistake, which now would essentially be 20 marks if you were to use the USAMO index calculation. One careless mistake here is 20 marks compared to 6 marks in the AMC. So certainly we want to do everything we can to avoid that. Alright, so this will be where we stop for part 1 of our review. You can stay tuned for in a few days time where we will go through part 2, which is questions 6 through 10.